Hi, this is Shiloh Lawrence at Nash Community College, and for the next few minutes we're going to talk about quadratic functions in standard form, which is f of x equals ax squared plus bx plus c. The graph of a quadratic function is called a parabola. A quadratic function in standard form, which is f of x equals ax squared plus bx plus c, opens either up or down depending on the value of a. If a is greater than 0, then the parabola opens up. If a is less than 0, then the parabola opens down. The point on the parabola where you turn around and change direction is called the vertex. Depending on whether the parabola opens up or down, the vertex will always contain either the minimum or maximum value for the quadratic function. If a is greater than 0, then we said the parabola will open up, and that means that our vertex is a minimum, or the lowest point on the graph. If a is less than 0, we said that means the parabola would open down, which is going to make the vertex the maximum, or the highest point on the graph. A parabola is symmetric with respect to the vertical line that passes through the vertex, which is called the axis of symmetry. For any quadratic function written in standard form, which we said is f of x equals ax squared plus bx plus c, the axis of symmetry can be found using the formula x equals negative b divided by 2a. Since the axis of symmetry passes through the vertex, this is also the x-coordinate of the vertex. The vertex is a point on the graph of the quadratic function. And being able to locate that point is essential to most application problems that involve quadratic functions, since this point represents the minimum or maximum value of the function. If we already know that the x-coordinate of the vertex can be found using the formula x equals negative b over 2a, we can find the y-coordinate by plugging this x value back into the quadratic function, thus calculating f of negative b over 2a. So our axis of symmetry is x equals negative b over 2a. We know the vertex shares the same x value of negative b over 2a, and the y value we get just by plugging our x value of negative b over 2a back into our quadratic function. For our first example, we want to find the axis of symmetry, the vertex, identify the vertex as being either the maximum or minimum, and sketch a graph of the quadratic function f of x equals negative 2x squared plus 8x minus 3. The first thing we're going to do is the axis of symmetry. We know that a quadratic function in standard form has an axis of symmetry that uses the formula x equals negative b over 2a. In our quadratic function, the b value is 8 and the a value is negative 2. So all we need to do is replace our b and our a with the values from our quadratic function and simplify. And we get that our axis of symmetry is the line x equals 2. That is half of the work for our vertex because we know the vertex shares the same x-coordinate of negative b over 2a. So we know the x-coordinate for the vertex is 2, and all we need to do is find the y-coordinate that goes with it by plugging 2 back into our quadratic function. So our vertex is going to be the point 2, f of 2. So everywhere in our function that I see in x, I'm going to replace it with a 2 and simplify, and we get that our y-coordinate is 5. So our vertex is the point 2, 5. Next, we can identify this vertex as being either a max or a min. Since we said our a value is negative 2, which is less than 0, that means our parabola will open down. And when the parabola opens down, the vertex, which is 2, 5 here, is going to be the highest point on the graph. So the vertex is our maximum. And finally, for a quick sketch of the graph, the first thing I'm going to do is I'm going to plot the point 2, 5, which is our vertex. And then we know we have a parabola that opens down from there. For our second example, we're going to do an application problem. An ice cream vendor uses the function f of x equals negative 35 thousandths x squared plus 6 3/10 x minus 247 5/10 to help estimate his daily ice cream sales, which is represented by f of x, based on the forecasted high temperature of the day, which is represented by x. The first thing we want to do is determine what forecasted high temperature will yield him a maximum amount of ice cream sales. And remember, x represented forecasted high temperature. So in part A, we want to find the x value at our maximum. And for part B, we want to know what the maximum number of ice cream sales were, which is f of x. In the problem statement, it says daily ice cream sales are f of x. So we want to know the y coordinate at our maximum. Well, since our function is a quadratic function, we know the maximum is going to be at the vertex. So to find our vertex, we're going to use the x coordinate of negative b over 2a. The b value in our quadratic function is 6 3/10, and the a value is negative 35 thousandths. So we'll replace them in this formula and simplify, and we get that we will have a maximum amount of ice cream sales when the forecasted high temperature is 90 degrees. Once we know the x coordinate, all we have to do is take that x value and plug it back into the function, because the function value f of x gives us daily ice cream sales. So we're going to plug 90 back into our function for x and simplify, and we get that the maximum amount of ice cream sales will be 36.